Our robot's primary task is to classify different colored objects. What it basically does is it takes certain colored objects and pushes them to the boundary of the vicinity it's in. For example, if the robot needs to take a red colored object towards the wall, then it will come to towards the object, detect the object's color. If it's red, then it'll grab the object, push it towards a wall, and once it's at the wall, it'll release the object and move back to find other objects. Our robot has 3 sensors, 2 ultrasonic sensors and 1 color sensor. The lower ultrasonic sensor is used to detect objects in front of it. So for example, if there's an object in front of it, we'll get a low distance reading from this ultrasonic sensor. The upper ultrasonic sensor is used to detect the distance of the wall in front of it. Now, because the object is at a lower height compared to this ultrasonic sensor, the objects do not interfere with the wall readings. The color sensor is used to detect the color of the object. Now, the card shows the color of the object, and if this sensor is on top of the card, it'll detect whatever color is the object is. Our robot also has 3 motors. 2 motors are used to help the robot navigate, and 1 motor, this one, is used to move its arm up or down. This arm is used to grab onto objects. The arm is made sufficiently large enough so that we can grab onto objects properly in many different scenarios, and once that's done, we can push the object around to a wall. In the first experiment, we use 1 robot to move 2 yellow and 1 red object towards the boundary. Here we see the robot detect a red object. Once it has determined that the color of the object is red and that it needs to move a red object, it'll grab onto it and push it to the boundary. Here we see the robot turn down its arm and push it to the boundary. Now, if it finds another red object in its path, then it will not pick it up anymore because it has crossed its limit of red objects. After dropping off the red object, it'll move away from the wall and continue in a random motion. If the robot finds its path blocked by a boundary, as we see here, it'll back up and continue in its motion to look for more objects. Now the robot sees a purple object, but since we do not require a purple object, the robot does not pick it up and backs off. Now the robot would continue on its motion and bump into a yellow object. Since yellow is one of the required colors, the robot will grab onto the object and drop it off towards a nearby boundary. In the second experiment, we used 2 robots to perform the task of moving 2 yellow and 1 red objects towards the boundary. Here we see 2 robots working together. Once they start, they will both detect the yellow objects in front of them and grab onto them, since we need 2 yellow objects to be moved to the boundary. The robots are connected to a server that controls them. Once the robots are on their way to the boundary, they let the server know that they have found a yellow-colored object each. The server updates the required number of objects of each color every time a robot pushes an object to a boundary. In this screenshot, we see the server's updated object color count once the robot picked up the 2 yellow objects. The required count for the yellow object reduces from 2 to 0. Now, since we do not require any more yellow objects, even if the robot finds another yellow object in its path, it will not pick it up. It will detect the object, detect its color, and move away since it has already found the required number of yellow objects.